Hello, welcome back. Critical thinking, challenging questions from igcse physics. It is a part 3 question. I have collected some questions from the past paper, old past paper. Let's discuss. Is a question number 1. Two objects x and y are identical in size. So there are two objects. Here is x, another object y, and they are in same in size. Size is same x and y. But the weight or the mass of x is 3 times greater than this, the y. It is 3 times greater. When they are both released at the same time from the same height and in an evacuated container. Now they are being dropped in the evacuated container, very long container. And they reach the floor of the container at the same time. The both of them, they reach the container, the bottom of the container at the same time. One is heavier, one is lighter, not the point, but they reach the ground at the same time. So which of the following is incorrect? The rate of change of velocity is the same for both x and y. Rate of change of velocity is known as acceleration. For the falling object, the acceleration is constant. That is, acceleration is known as gravitational field strength, or the acceleration due to gravity will be same. So the option is correct. Here you have to be very careful. They ask which line, which sentence is incorrect. Option is incorrect. This option is correct option. It is not incorrect because the rate of change of velocity is same for both of them. On reaching the floor, speed of x is the same as the speed of y. What do you think? This heavier object speed will be different than the lighter one or the same? We can check. Now for the object x, I want to find initial speed is 0 for both object. The initial speed u is 0, and I want to find the final. So what is the formula? U plus gt, because vertical motion. Here also u plus gt. So initial speed is 0, the g value is 10, the time 1 second. Here initial 0, g value is 10, and time is here 1 second or 2 second or 3 second. It is applicable for both because at same time they reach the ground at the same time. So the speed will be the same. The final speed for both object, whether it is heavier or lighter, irrespect, it is not at all going to depend. It is independent. Mass is independent for this. So the option B is correct option. This is not incorrect. Third option, on reaching the floor, the kinetic energy of x is greater than that of y. So immediately students will select this because here the speed is same. Example, here 10 meter per second when it hit, here also 10 meter per second. So the speed of the both objects are the same. So the kinetic energy will not be greater or less than, will be the same, right? Immediately students will select this is the wrong option, but this is the right option because the speed is same for both objects. But what about the mass? Kinetic energy depends on mass. What is the formula? Half mv square. Here is half mv square. Here the velocity is same, but the mass, what about the mass? Here this mass is greater, this mass is less. So greater mass you multiply, the kinetic energy will be greater. So the last option, this is incorrect option. The size of the force acting on x is the same as the size of force acting on y. This is not correct because here this object mass 3x we have taken, for example 3 kilogram, and the another object mass is 1 kilogram. So I want to find the force acting on the object to pull the object downwards. That is F is equal to ma. So mass is 3 kilogram. Acceleration is the gravity, due to gravity. So it is 10. It is 9.8 or 10 for easy calculation. We can take 10. So it is 30 Newton is being acted upon. Is the 30 Newton of force is being acting onto this object. And here how much? F is equal to ma. The mass is 1. Acceleration is 10. So 10 Newton, only 10 Newton is acting on this. So the force is not the same as this sentence is saying. Force acting on X is the same, not same. It is bigger. The force on this object is bigger than the another object. Okay. Hope you understand this question. Let's discuss the second one. Second question. Here, a non-uniform rod Mn. This is the rod and it is a non-uniform, not this point, non-uniform. What is non-uniform? We cannot decide the center of gravity exact point. The length of the rod is 100 centimeter and it is suspended by two spring balances X and Y. Here is X and here is Y. It is being supported or suspended. So the rod is balanced now at this position. The position of spring balance X is here 0 and the spring balance Y position is 80. Okay, now what are we going to find? The at which mark is the center of gravity of the rod, and which point the center of gravity? We are going to find the center of gravity. Where is the center of gravity? Since it is a non-uniform rod, it is not going to act at the center. We are going to find out. And what are the given information? The scale reading, the spring balance, the reading on the spring balance is double that of spring balance X. So here you can say 2 Newton force is acting to pull this upwards. The spring balance uh, is pulling the rod upwards, right? This one is the rod is the rod pulls the spring balance downwards and the spring balance pull the rod upwards. So it is like that. Okay, so the reading here is 2 Newton. Here will be 1 Newton according to the question. It says, the question says, not me, the question. Okay, now I want to find the center of gravity of the rod. So what is the formula here? We take one object, one spring balance as a pivot. So I want to take this one as a pivot, a fixed point, a fulcrum. I have to find out how many forces are being acted upon this system. There are two forces. One force is the pulling force, upward pulling force by the spring balance. That one I can take as F1. Another force is the center of mass of the rod somewhere here. We don't know that exactly. So this force we can take as F2. So the F2 force is making anti-clockwise moment and then F1 force will make clockwise moment. So we can write here the moment of equilibrium. It says clockwise moment is equal to anti-clockwise moment. So we can write F1 D1, the formula for the moment F into D, F2 D2. So here the force 1 is given. It is 2 times bigger than the spring balance X. So here 2 Newton. And the perpendicular distance from the pivot to the force, 80 centimeter. And F2, the weight of the rod. Weight of the rod is not given, but we should know. How do we find the weight of the rod? Here we know that sum of upward force is equal to sum of downward force. Upward force, there are two spring balances. One balance will show 2 Newton, another is 1 Newton. So total upward force 3 Newton. So the total downward force also 3 Newton. So here I can write 3 Newton multiplied by the perpendicular distance I want to find, D2. That's all. Now D2 is equal to 2 Newton multiplied by 80 divided by 3 Newton. Newton cancelled. So 160 divided by 3, 53.3 centimeter is the answer. Like that we have to sort out the problem. So here the important concept is to find uh, the total upward force is equal to total downward force. Sum of upward is equal to sum of downward. This is the trick. Here is a tree. Okay, let's discuss the third question. The diagram shows a cyclist traveling at a speed of 10 meter per second. So here the speed of this point is 10 meter per second. He travels up a slope without further pedaling. When he is traveling up without pedaling, he is traveling up and he will be stopping somewhere. The gravitational field strength 10, G value is given. Ignoring friction, so there is no energy loss. The total the energy, the total energy, kinetic energy will be converted into gravitational potential energy as it is going up against the gravity. It is gaining gravitational potential energy. The maximum height h which he reaches, so we have to find the maximum height. So here he is having the kinetic energy. As per energy conservation, kinetic energy will be converted to gravitational potential energy because he is moving up the hill. So he is gaining gravitational potential energy. So you can write kinetic energy will be converted to gravitational potential energy. If he has 100 joules, the gravitational potential will be 100 joule, nothing more or less, because energy conservation, conserved energy is conserved, and ignoring friction, so there is no heat energy loss. So you write the formula, half mv square is equal to mgh. So here the mass of the system is constant, the bicyclist mass is cancelled. So what the remaining here, v square divided by 2 is equal to gh. I want to find the h, the height. So this g will go to the denominator, v square divided by 2g. That's all. This is the formula. What is the speed? Speed is 10. 10 square divided by 2 multiply g value is 10. So the 100 divided by 20 is equal to 5 meter is the answer. 5 meter. He will go up 5 meter above the ground. I hope you understand this concept. Question number 4. Water of density 1000 kilogram fills up to a water level of 20 centimeter in a tall vase. There is a water which has the density that is a rho, 1000 kilogram per meter cube, fills up to a water level of 20 centimeter. So there is a tall vase. They are filling water into the tall vase, which is 20 centimeter length. That is the height. Height is here, h. When the base of the vase cracked, here it is cracked here at the base, water starts to leak from a tiny hole of area 1 millimeter square. So there is a small hole, the area is 1 millimeter square. So a sticky tape is then used to cover the hole and to prevent the water from leaking out. The gravitational field strength G is given. What is the maximum force that the tape can withstand? So I have to find the maximum force that tape can withstand. So here this concept is liquid pressure, because the total weight of the liquid acting at the base, and then it gives a force acting on the area. Force acting on the area gives the pressure, right? So the liquid pressure formula is rho gh. The density of the liquid is here 1000, g value is 10, the height value is 20 centimeter. I should change into meter. So I can cancel the zeros. The final answer is 2000 Pascal. This is the pressure, the total pressure the water is acting onto the container at the base level, 20 centimeter base level. At the base, 2000 Pascal. Now what is the maximum force which can withstand? Means the same force what the water is producing onto the crack. So how can we find? This is the formula, another formula, that is P is equal to force divided by area. Pressure is equal to force divided by area. I want to find the force. So multiply this, cross multiply, pressure multiply by area. What is the pressure exerted by the water? 2000 Pascal. We found it here. What is the area of the hole? The area of the hole is a 1 millimeter square. So 1 millimeter square. Now I will teach you how to change into meter square, because here is Pascal, that is the SI unit. So I should change millimeter square into meter square into the SI unit. So how I'm going to change it, listen. So this one I can write here 1 millimeter. Milli is 10 to the power minus 3, that we have to by heart. And meter, you can write meter. And this square, you can write the square. The next step, 2000 into 1 is 2000, and this 10 to the power minus 3 square will be 10 to the power minus 6, and meter square is meter square. And now this, using calculator, you will be getting 2 times 10 to the power minus 3 meter square, and here is Newton per meter square. So meter square is cancel. So you will get 2 times 10 to the power minus 3 Newton. Right? This meter square, this Pascal has Newton per meter square. So meter square cancel. Finally, the answer is Newton, the force. Now we found the force. Is this clear? So the option is here, A is the option.